So this homework has two distinct objectives. The first one is showing that I can use geometric properties to calculate the capacitance of a capacitor. So I've drawn my little circuit down here. We're just going to be paying attention to the top portion of it for this first part. So we're going up here, going around, having a great time. Anyway, here's the capacitor. I've drawn it as two circles separated by distance s. I've given my r value, my radius, as 2 meters, and I've defined my s, the distance between the two, as 1 millimeter. So there are a few different equations we have to calculate for capacitance that we've talked about in class. However, this one is the only one we care about as far as talking about solely geometric properties. This one uses, your electron density and your electron mobility. You don't care about that. This one has total charge and the delta V, the change in voltage, so we don't really want that either. So anyway, we're going to use this one because it just uses area and the distance between the two and epsilon naught, which is a constant. How wonderful. Anyway, so if we plug in C equals all these things, we end up with 8.85 times 10 to the negative 12 equals pi r squared, again, r being the 2, divided by 1 millimeter. And we end up with a capacitance of 1.11 times 10 to the negative 7. So the second part, or the second objective, is showing that I can calculate the equivalent capacitance and how well capacitors add together in a circuit. So for the case of this, I'm just going to pretend this top, it splits by node rule. 0 volts go up here and all of them come down here, because I probably should have just made it like 20 or something and split it, but I didn't, so fuck it. Oh, shouldn't have cursed. Anyway, so it splits down here. I've given a capacitance of defined it as 2 Faradays for each of these, and since it's in series, we get to use this equation of epsilon minus q, q being the total charge we're trying to solve for, equals 1 over the capacitance equation, so all the capacitance is combined together, equals 0. So we end up with, when we plug in all of our numbers, 15 volts minus q, again the value we're trying to solve for, multiply by 1 over 2 plus 1 over 2 plus 1 over 2 equals 0. Do some fun math, which is really easy, and just add up 1 half, 1 half, 1 half. We end up with 15 minus q times 1 half equals 0. Do some basic algebra, and we end up with q, which is the total charge that's shared between all of them, as 10. So all of these individual capacitors have a charge of 10 on each side. So negative 10, excuse me, yeah. Negative 10, positive 10, negative 10, positive 10, negative 10, positive 10, and it goes all the way around. And goes back and completes the circuit. And I think that's it. Thank you very much. Bye.